The forest is quiet, too quiet. A lone hiker vanished without a trace. GPS logs show a clear path, but drone footage reveals one extra shadow. Campsite records tell a story, incomplete. What happened in the wild? Who was that shadow? Step closer. Together, we will uncover the truth.
Hi, welcome to this crime case. Let's solve this mystery together, step by step. We have a missing hiker, a shadowy companion, and some strange data. Our job? Use the evidence to uncover what really happened. Ready? Let's dive in. First, we need to gather our evidence. We'll look at three key data sets: GPS trail logs, drone surveillance logs, and campsite reservations. Each one could hold a vital clue. Let's see what secrets they reveal about the hiker's movements and identities. First things first, we need the right tools for the job. By typing import pandas as PD, we're bringing in a powerful Python library called Pandas. Think of Pandas as our digital detective's notebook. It helps us organize, read, and analyze all sorts of data. We're giving it a nickname, PD, so we don't have to type the whole name every time. This is like grabbing our magnifying glass before we start looking for clues. Now, let's pull up our first piece of evidence. Here, I'm creating a variable called GPS_DF. That's just a name we'll use to store our data. The code pd.read_CSV tells Python to read a file called GPS_trail_logs.csv. This file holds all the GPS trail logs, basically a digital footprint of everyone's movements in the area. By loading it into our variable, we can start searching for patterns or maybe even spot someone who was somewhere they shouldn't have been. Next up, we're adding another layer to our investigation. I'm creating a variable named drone_DIF and using pd.read_CSV again, this time to open drone_footage_log.csv. This file contains logs from the drone footage, so we'll be able to compare what the drone saw with the GPS data. By storing it in drone_DF, we can easily cross-reference these two sources and look for any inconsistencies or missing timeframes. And finally, let's bring in the guest list. Here I'm creating a variable called campsite_DF and loading in campsite_reservations.csv using Pandas. This file tells us who officially reserved a spot at the campsite, our list of suspects, witnesses, and maybe even a red herring or two. With all three datasets loaded, we're ready to start connecting the dots and see where the evidence leads. Now let's take a first look at our evidence. We'll pick at the top rows of each dataset. This helps us get familiar with the data and spot anything unusual right away. First things first, let's shine a spotlight on the GPS trail logs. By typing print, open parenthesis, then 3 dashes, GPS trail logs, and close parenthesis, we're telling Python to display a headline in our console. This helps us organize our findings almost like labeling a folder at a crime scene. Now let's actually look at the GPS data itself. When I type print, open parenthesis, GPS_DF, close parenthesis, I'm asking Python to show us the contents of a variable called GPS_DF. In Python, a variable is like a box where we store information, in this case, all the GPS logs. This will let us see where everyone's been moving around the park and maybe spot someone who took a detour. Next, I want to separate out the next piece of evidence. By printing a new header, 3 dashes, drone footage log. We're making it clear that we're switching gears. This is just another print statement, but it helps us keep our clues organized as we dig deeper. Let's pull up the drone footage log. When I type print, open parenthesis, drone_DF, close parenthesis, Python will show us the contents of the drone_DF variable. Think of this as a digital box filled with all the drone's recordings. Maybe we'll spot someone lurking where they shouldn't be. Alright, time to check another angle. By printing out a new header, 3 dashes, campsite reservations, we're setting up to review who officially booked a spot at the campsite. Again, this is just a print statement, but it's like flipping to a new page in our case file. Finally, let's see the actual list of campsite reservations. When I print campsite _df, Python will display all the reservation records stored in that variable. This could be our guest list, and maybe, just maybe, someone's name will jump out as suspicious. Look closely at these first clues. The GPS logs mention both Riley and someone called unknown. The drone log shows how many people were seen at different spots and times. The campsite reservations only list 3 names. This is where things get interesting. Let's focus on the GPS logs to track who went where and when. First things first, let's make sense of the timeline. We need to convert those raw timestamps into something Python can actually understand. This will help us spot any odd movements later on. Here, I'm telling Python to take the timestamp column from our GPS _df, that's our table of GPS data, and turn each entry into a real datetime object. The format %h:%m means we're looking at hours and minutes just like on a clock. This way, we can compare times and catch anyone who might have slipped away unnoticed. Now, let's put these records in order. I'm sorting our GPS _df by the timestamp column so we can see every movement as it happened, minute by minute. Sorting like this is key. It's like lining up all the suspects' alibis to spot any gaps. And here's our sorted GPS _df, the full timeline laid out before us. With the data in order, we're ready to look for anything that doesn't add up. Now let's analyze the GPS trails. Both Riley and the unknown hiker show up at Eagle Ridge and Pine Lake. The unknown hiker always arrives just after Riley. Are they following or meeting up? Let's compare their paths and timing more closely. Alright, let's set the scene. We're about to look for places where our suspects might have crossed paths, and times when they were dangerously close together. This is where the investigation gets interesting. Here, I'm creating something called a pivot table from our GPS data. Think of it like a big detective's board. Each row is a location, and each column is a hiker's name. For every spot, we'll see the first time each hiker showed up there. In Python, we use the pivot table function to reorganize our clues, making it way easier to spot overlaps. Now, I'm dropping any locations where we don't have info for both hikers. In Python, that's what dropna does. It removes any rows with missing data. So we're left only with the places where both Riley and our mysterious unknown were present. The plot thickens. Next, I'm calculating the time difference in minutes between when unknown and Riley were at each overlapping location. Here, I'm creating a new column called time_diff_min. By subtracting Riley's timestamp from unknowns and converting the result to minutes, we can see just how close their paths came to crossing. This is where Python's datetime magic helps us measure those crucial moments. And now let's take a look at our overlaps variable. This is our evidence board, showing every spot where Riley and unknown were both present, and exactly how many minutes apart they were. Are we about to find the smoking gun? Let's see what the data reveals. Here's what we find. At both Eagle Ridge and Pine Lake, the unknown hiker arrives just minutes after Riley. This suggests they were traveling together or one was following the other. But is there more proof? Let's check the drone footage for backup. Alright, before we dive in, let's set the scene. We're about to convert the drone's timestamps into something we can actually work with. This is where we start making sense of when things happened during the crime. Here, I'm telling Python to take the time column from our drone _df, that's our drone data frame, and turn those time strings into real datetime objects. Basically, we're teaching Python to read the times as actual clock times, not just plain text, That way we can compare moments and spot anything out of the ordinary. Next, I'm making sure the num underline people column is full of actual numbers, not just words that look like numbers. By using the asType function and setting it to int, we're converting every entry into an integer. This lets us do math later, like counting how many people were seen at each moment. Every detail counts in our investigation. And now let's take a look at our updated drone underline DF. This is our evidence board, all the times and the number of people the drone spotted neatly organized. From here, we'll start searching for patterns and hopefully uncover a clue. The drone footage adds another layer. It shows 2 people at Eagle Ridge and Pine Lake matching the GPS overlaps. At other spots, only 1 person is seen. Let's make a chart to see these patterns over time. First things first, we need the right tools for our investigation. Here, I'm importing matplotlib.pyplot as PLT. Think of this as grabbing our magnifying glass. It's a powerful Python library that lets us visualize data so we can spot patterns and anomalies in the evidence. Now, I'm setting up the canvas for our crime scene. With plt.figure, I'm choosing a figure size of 8 by 4. This just means our chart will be wide enough to catch every detail, like a detective laying out a big map on the table. Here's where things get interesting. I'm plotting drone underline DF, that's our drone data frame, using the time column for the x-axis and num underline people for the y-axis. Each point, marked with a little circle, shows how many people the drone spotted at each moment. This is like replaying the surveillance footage, frame by frame, to see when the crowd changed. Let's give our chart a title so we know exactly what we're looking at. With plt.title, I'm labeling it number of people detected by drone over time. This helps us, and anyone else on the case, stay focused on the key evidence. Next, I'm adding a label to the x-axis with plt.xlabel. I'll call it time. This way, we know exactly when each event happened, crucial for piecing together the timeline of the crime. And now I'm labeling the y-axis with plt.ylabel, naming it number of people. This tells us what those numbers mean. Every spike or dip could be a clue about when someone entered or left the scene. To make sure we don't miss any subtle changes, I'm turning on the grid with plt.grid set to true. This adds lines across our chart, making it easier to line up the evidence and spot anything unusual. Alright, moment of truth. Plot.show reveals the chart. Now we can see the whole story unfold. Every movement, every gathering, every possible clue right there in the data. Let's see what secrets the drone footage holds. Look at this chart. 2 people are seen together at Eagle Ridge and Pine Lake, but at Forest Bend and Campsite 4, only 1 person appears. The pattern is clear. Now let's check if the unknown hiker ever registered at a campsite. Alright, let's start by pulling up our main piece of evidence, the campsite underline DF. In Python, when you see a name like this, it's called a variable. Think of it as a labeled box where we're storing all the data from the campsite. Every guest, every check-in, every detail. This is our foundation for cracking the case. Here's what we find. Only Riley, Sam, and Morgan are listed. The unknown hiker is missing from the records. This supports the idea that they were unregistered. Let's see who was supposed to be at Campsite 4, where Riley was last seen. Alright, let's start by asking the big question. Who checked in at Campsite 4? This is where our investigation begins. Here, I'm using Python to filter our campsite data. I'm telling the computer, show me only the rows where the campsite column equals Campsite 4. In Python, that's done with the square brackets and a double equal sign, which means we're checking for an exact match. This way, we'll see just the records for Campsite 4 and maybe spot our first clue. Now for the big reveal. The GPS and drone data prove Riley was not alone at key moments. The unknown hiker was close by at Eagle Ridge and Pine Lake, but never registered at any campsite. At campsite 4, only Riley is listed, and the drone saw just one person after dark. So, who was the shadowy companion? The data shows they were with Riley until just before the disappearance. But their identity remains a mystery. Our investigation has brought us closer to the truth, but the case isn't closed yet. Stay curious, detectives!